right, now it is recording. This is a explanation of going through the linear programming assignment. I'm hoping that the resolution is going to be improved on this. Let's make sure it is by zooming in. So linear programming, what is it? Well, let's look at the slide here. It's a technique for maximizing or minimizing the linear function of several variables. So I like to look at this as an example of how many of each item to build. If you have limited resources and you have two products that you can build that have different production costs and different sales values, you can use this marketing, or you can use this mathematical technique to determine how many of each you should build to maximize or minimize something. You could try to maximize profit. You could try to minimize workplace accidents. If like certain products have a certain amount of safety incidents with it, you could try to minimize that. You try to maximize something. We'll try to maximize profit again in this class, but you can maximize other things too. You could, if you were a very generous employer, you could try to maximize overtime hours. You could try to minimize overtime hours. You could, anything that you could, well, not anything, but a lot of things you could think of with this, you could build into a linear programming model. Now, this is the first time I'm kind of deviating. Before I would start with this marketing mix problem, I'm not going to have us go through that because I think that's kind of overwhelming. I'll talk through it at a high level as an example of something you could solve with this. If you were making an advertising campaign and you had to choose from TV spots, website ads, a newspaper ad, or a radio ad, so this kind of feels a little dated, but if you had those things to choose from and there were different costs for each, different number of potential customers reached by each one, and how different amount of times they're available and how good of a quality unit they are. So some pretty, that's kind of abstract, but you can take these different things and build them into a linear program that will tell you how many TV ads you should buy, how many website ads you should buy, how many newspaper ads and radio ads. So it does that decision making for you instead of you looking at 30,000 possible scenarios. It does it for you and says this will maximize the number of people that you reach, or this will maximize the exposure quality units number, whatever you want to look at. And then you can build things in like saying, I want to have at least 10 daytime TV ads. Well, you can build that in and you can say, you know, maximize profit with this constraint. So if you wanted to, you can do that in your Excel file. I have that built and you can play around with it. But I think instead of doing that here, it's more valuable to do start with a simpler problem, which is actually going to be, this is going to be your homework problem. So pay attention to this, but also this video will be posted tonight. Let me write that down. I'll post this tonight so you can reference this as you do the homework. But we've got a problem to solve here. It's a toy store that sells two types of toys, A and B. So I'm not very creative, but they have an A toy and a B toy, and the store owner, the cost to each, like A is $8 and B is $14, and this represents their inventory cost, and the profit for each is $2 and $3. So you're making a profit of $2 for each of toy A that you sell and $3 for toy B that you sell. And you need to decide how many that you can build. And you have a maximum amount of inventory cost that you can withstand, and that's stated here. There's $20,000 of inventory costs that you can incur. So that's a constraint. So you have to find out how many of toy A and B to build within this inventory cost of $20,000. And you can only sell 2,000 per month. So that's a constraint that I'm putting on you for us to figure out how to get around it, or how to fall within that. So you can sell 2,000. Your inventory costs can only be 20,000. So you need to limit, that you're gonna have to consider that when you're determining how many of A and B to order or build. And we're trying to maximize our profit here. So there are some formulas that you have to build. Actually, I'll upload this template, so they'll be there for you, but you'll have to reference these. There is, let me write this down. All right. I'm making a list of stuff for myself so I don't forget after this video. All right, so I will upload this template so you can use it. But there are some formulas. This is from a previous student actually created this. And she put an inventory formula here. And the inventory formula, again, this is not an Excel class, but what she did is she created an inventory formula that compared the cost and the number built of toy A plus the cost and number built of toy B. So added those together. So if you manually fill this out and you make one of toy A, you see it adjust over here, and you make one of toy B, you get an inventory cost of $22, which you would expect because because that's how the math works out. If you do two of toy B, it's $28 plus $8 for one toy A, and you get $36. What linear programming does in a nutshell is it just rifles through a bunch of different combinations in here, and it will keep rifling through all those numbers until it exhausts all the possibilities, and it retains the highest whatever you decide you want to maximize or minimize. It'll find the highest or lowest of that. So in this case, we're looking at the highest profit. So you're going to come up with an equation to point to find that profit. And you're going to tell linear programming, here's the thing that I want to maximize or minimize. Go find out how to do that for me. There's another formula that she built for a number of toys built. And that way, you know that this number, you can compare it in the linear program to be less than the number built, or less than or equal to. And then profit is what we're going to try to maximize here. So inventory should always be less than or equal to this. Number built should always be less than or equal to this. And profit is going to be as high as we want it to be. So let's do that with linear programming. Now, this in Libre, I do not think we can do this in LibreOffice, but there is a third-party website, and I will send information how to do it on a third-party website so that you can still accomplish this.
Thank you.
I'm sorry?
Thank you.
Yeah, yep, no worries. I don't think it's possible. I'll try to look, but I know you can do it on a third-party site, so that's all good. But in Excel, we'll go over how to do it here. What you're gonna do is I have in the PowerPoint to show you how to get to the solver in Excel in case, well, I'll show you in the video, but in case you need to see it in the PowerPoint, it's there. So we are going to use solver, and these things are already filled out. That's fine. All right, so we're gonna set, the first thing we need to do is set an objective cell, which is what we're gonna maximize or minimize. And so Bobby, she was the previous student who built this. She made her objective cell J18, which is her profit cell, which that is correct because we want to maximize profit. So the next step is you decide if you want to maximize or minimize, or you can try to hit an exact value of something if you wanted. So I guess when I said you could maximize or minimize, there's a third option. You could find an exact value. But generally you'll want to maximize or minimize something. So we're going to try to find the maximum value in cell J18. And we're going to do that by changing the variable cells in B15 and C15. So you hit this, you click in here, and then you just select the cells that you want to change, and then it populates in here. Or you could hand type in the cells that you want to look at. This is when I said it rifles through a bunch of numbers. That's what this is telling. This is what you're telling it to rifle through. You're going to rifle through these two different cells and just pump a bunch of numbers in. And whatever combination maximizes the profit, that's what we want to select. So there are some constraints here. It's okay. Looks like we're making B15. So Bobby, you don't necessarily have to do this, but Bobby went ahead and made sure that cell B15 was going to be an integer and that C15 were going to be integers. That's you just telling it that it's going to be a number. Oh, you know what? Bobby did need to do this. Yes, this is important. You want to force it to be an integer because you don't want it to be like a half of a toy. You can't really build half of a toy because that's worthless. So you're going to force it. You're going to force it to be an integer. You could also force it to be, you type it to be, yeah, you can hand type in like I don't know if you can do a string, but you could do like a double or a different like number type, but we're going to force it to be an integer. Yeah. And so we've got those two. Change this. Integer. Okay. So and then I need to slow down. Does anybody have any questions so far? Or is anybody lost?
I'm okay.
My only question is once I get it typed into the top bar, how do I add it to the subject to the constraints? Do I just click add?
Subject to, you're talking about here in the middle?
Yeah.
Yeah, okay. So yes, you type add and then you can add in a constraint. And
Then I
so
just retype it in here.
yeah, so like which one are you trying to do? Are you trying to
B15, the C15, the one that's in your top bar right now.
Yeah, well, okay, let me just delete these and we can, that is better. I will delete these so we can start from scratch together. All right, so you hit add and then you type in, like if you want to force this to be an integer, you put in the cell that you want to force to be like a solid whole number, and then you just select int from the drop down and hit add, and you can do another one, and then if you hit OK, it'll take you back and you should see that you've just added those two constraints. Did that solve what you were looking for?
Yes, thank you.
Cool. Good question. Yes, this is going to be a good video. So awesome. All right. So we've got those two constraints, but now there's two more constraints that we need to add, which are, we need to make sure that our inventory never gets above 20 grand. So Bobby's already built this formula for us. So tip of the hat to Bobby from 2 semesters ago, but we're gonna click on inventory and we're gonna make sure that it is less than or equal to our constraint, which is this number. So does that make sense why we did that and how that's working? Okay, cool. But I'll go to the next one and then we'll have it work and then we can see how it works and then we can see if that makes sense then. Let's add another, there's one more constraint. The number of units sold. So click that. Oh wait, sorry. T built is going to be, let's see, less than or equal to our constraint of 2,000. So the constraint's always going to be your ceiling or your floor of how much you're going to do. Now we're going to always have less than or equal to that. We're going to hit OK. And so we've got our constraints built in. We've got our objective function, which is where our profit is calculated. And then we've got the variable cells that we're going to pump numbers through. This should be on by default, but if it's not, you want to make unconstrained variables non-negative. What that means is you can't build a negative number of toys. Like you can't build a negative number of toy A or B. So you check this and it will make sure there's no negative numbers. And then we're going to use GRG nonlinear. You could use simplex LP. We're going to use GRG nonlinear. And we're going to go ahead and if I needed you to change that or specify that, I would tell you. So we're going to use the default there and we're going to hit solve. And when I hit solve, excuse me, got something in my throat. Okay, so when I hit solve, we're not going to see it happen, but it's going to go through and it's going to give us a solution on how many of toy A and B we should build. So let's hit solve. It's going to do its thing. It calculated, and then it went ahead and gave us our scenario. So if we build 1,333 of toy A and 666 of toy B, kind of a cursed amount. That was not on purpose. So if we do that, we have an inventory that falls within our constraints. So it is under 20,000 in inventory. And the number built, we hit that exactly, 2,000, and we maximized our profit. Does that make sense, or does anybody have questions on what this is doing? Cool.
I don't have any questions.
Yeah, I'll be okay once I get my technology to work.
Yes. Okay, cool. Are you having a problem with, you're using Excel, right, Sylvia?
Yeah, I am. I'm just having a problem adding them. It keeps saying it has something about a numerical value. It's just not letting me do it.
Oh, for which,
For the top, I'm doing the B15 cell to equal an integer.
cool. Okay. Would you mind sharing your screen so we can get this on video for future?
Oh goodness. Okay.
Oh, you don't have to. If you don't want to, that's fine.
It says host disabled participant screen sharing.
Oh yeah. Yeah. I do have that disabled. Okay. Try now.
You cannot start screen share while the other participant. Okay, hold on. All right, it's going. I think it's this.
Cool. Okay. Thank you for sharing this.
Okay, so do I click integer and then go to equals? Is this not right?
No, go. So you're trying to make sure that B15 is, yeah. So Just do integer. I think I did what you're doing first, and I should not have done that.
Just
Yeah.
leave it here.
Yep, and just hit add.
Oh, that's what I'm doing wrong then, I think.
So, and then yeah, well, let's watch you finish this since I did
Oh,
mine.
no, it's okay.
No, let's do. Come on, yeah, that's all. We'll get it working. If
Oh,
you want to, we don't have to, but
no. Okay, how do I check if that works though?
what's that?
Did I click okay?
Oh, if you hit yeah, so it's already added it, but you can hit cancel, and then you should go back and see it.
Gotcha. Okay. So now I will click the C15 one.
Well, no, so that is kind of unrelated to what you're doing. What you're going to want to click there is you're going to want to select B and C15. So select both of those. Okay, so that's good because that's what those are the variable cells that you're going to be pumping numbers through, right? So that's but then now hit add again. And that's kind of unrelated to what you just typed in. So that's good. So now you want to select C15.
Gotcha.
We make that an integer. Yep. And then hit OK. If you hit OK, it'll take you back. So you can
Okay.
you reassured it's there, and then you can hit add again because we're going to have 2 more constraints. And do you remember what our 2 other constraints are going to be?
Is it J16? I don't remember.
Yes, J16 is one of them.
Okay. This is my way. Okay. J16.
And
By itself, or do I highlight?
good question. No, it's so J16 is our inventory, and so that's our cell reference, and the constraint is actually going to be in cell
G13, was it?
yes, yep. And we want it to be less than or equal to that value. So that's fine. That's perfect.
Okay.
Because the alligator is eating the higher number. That's how
Right. That's how I remember it.
yeah.
And then add again.
Yep. One more.
J17. The constraint is H13.
Yeah. Booyah.
That's cool.
Perfect. And then you got your objective of J18. Yep. Dope. All right. So if you hit
Good to
solve,
go?
it should work. Yep.
Oh,
No, it's good. Oh wait. Hit OK.
okay.
What the heck? All right. So something.
Shit.
So, you're on video. You can't. No,
Sorry.
no, you're good. So if you go to click into cell click into cell J16. Okay.
Did I type the formulas in wrong? I was kind of winging it when you were explaining.
Oh, you typed those in? Okay. So click in your formula bar, like at the top.
Okay.
Okay, that looks good. So that one's fine. And then look at your J17. Okay, that one's good. And then that one, profit is good. Okay, so now what the heck? All right, click your linear programming again.
Up here, the solver.
Yeah. The solver, sorry, yeah.
It won't let me. Hold on. There we go.
Okay, so let's look at this. J18, yes. You're gonna find the max. You're gonna change the variables B15 to C15. B15 is an integer. C15 is an integer. J16 is gonna be less than or equal to. Oh, duh. Okay, hit close. Hit close.
Close.
So you're comparing to cell G13 and H13, but you've told it that you want those constraints to be 0. you actually need to make the maximum inventory 20,000.
Gotcha.
So, and then
2,000.
that's 2,000. Yep. Yeah, I should have seen that. So hit the solver again and now do it.
So
Sylvia, you did it.
I did.
That's perfect. You got 1,334 of toy A and 666 of toy B. So now if you hit solver again, just for fun, because this is so much fun. If you, instead of hitting a max, try to find the minimum profit and see what it does. I don't remember what it does here. Let's see. It might be an inverse. Oh, it builds 0. Okay, duh. You're just not going to build anything. So your minimum value would be that.
Max. This looks better.
That looks better. And then if you wanted to, I'm not going to make you do it, but if you wanted to say you had a contract that you had to build at least 100 of toy A. Actually, if you let me, I'll take this.
Stop sharing.
Yeah. So
Cool.
I'll show you how to do that. Thank you for sharing your screen. That.
Yeah. Thank you.
So if let's just for proof of concept, if we did want to find the minimum. Okay. So 0 and 0. But you had like some sort of union contract or a supplier contract where you, toy A min, toy B min, where you had to build at least 100 of toy A and 20 of toy B for whatever reason. If that's a new constraint that's thrown at you, you build that in here and you would just say that toy A must be greater than or equal to that. So you just add it, and then toy B needs to be greater than or equal, or let's say well, no. You could make it has to be 20 exactly if you wanted to, but you could do this and you could hit OK. And it's going to find the minimum with those constraints. And wouldn't you know it, that tells you to meet the bare minimum of that. So you can build constraints in, like examples of that would be if you're a car maker and you have to have at least like 60% of your parts sourced from the USA or whatever, like if there's tariff concerns, you could put a constraint in like that and then force it to comply with those additional constraints that get built in. So that's linear programming, and that's how you could solve complicated problems like that. Does anybody have any questions, or have there been any? I know, Amanda, you're kind of holding off to getting the website version, but like overall with the theory of it, does anybody have any questions or concerns of how you would actually use this in real life?
I'm good.
Cool. Okay, well, I'm gonna stop recording because it makes me nervous, but I don't know how to stop recording. Stop recording.